In this tutorial, we will go over how to perform all possible regressions as well as the various automated search procedures using R. The dataset that we're using is the NFL dataset from the 1976 season, which tries to predict the number of games won during the season based on a number of different explanatory variables. We will just read in the data as usual and attach it. And as usual, I always like to just take a look at the data set just to see the dimensions. So we know 28 teams in the 1976 season, 1 response variable, and 9 potential predictors. So to perform all possible regressions, the function that we use for that is found in the library leaps. So I'm just going to load it. Right? I'm assuming that maybe you already installed it. If you've not, please install the package. Load the library leaps, and I'm going to perform all possible regressions. The function that we use is regsubsets, and this is saying I'm using the data frame called data. My response variable is the variable labeled as y, and then I do a tilde and a period. The period just means that I'm considering all the other columns as potential predictors for the response variable y. You have to specify what data frame you're using. You also this n-best just basically says for all potential sizes of the model, right? How many of them do you want to consider? So if I set n-best to be equal to 9, then for the first thing that they'll consider will be the regression model with just one predictor, and they'll consider the 9 best models with just one predictor, and then they'll consider the 9 best models with 2 predictors. So let me just run this and kind of just show what I mean with that. Now, before I go into that though, I want to point out the following. Right, so I've stored my reg subsets into this variable called allreg. If you want to just type in something, like using the summary function with allreg, you realize that it doesn't look very nice visually. Like, it gets a little bit confusing, like false, and then all these open quotes and the star. It's a little bit difficult to see visually. So personally, what I like to do is I like to create a quote-unquote data frame that will store all these different predictors as well as the different criteria like the R-square, adjusted R-square, the mean square error, malloc, CP, and BIC for all of them. All right, so basically what this is trying to do is it's saying if I only consider one predictor, the best predictor to add in is the 8th predictor. Right, and then the next best one is the first predictor, right? So you consider the 9 best of these. That's where this n best equals 9 comes in. And then you consider models with 2 predictors. So the best model with 2 predictors has x2 and x8 in it. The next one will be x2 and x7. And you consider the 9 best models just with 2 predictors. So that's what this n best represents. I typically like to use a number bigger than 1. If you have a huge data set, you might want to stop this n best to be maybe no more than 10. Just because if you have a big data set, there's just too many models to take a look at. So I'm going to basically use this function here this line basically gets rid of the quotes. I personally don't like it. And then I'm going to create extra columns where each column will give me the number of coefficients, the R-square, adjusted R-square, mean square error, malloc, CP, as well as BIC. From regsubsets. I believe regsubsets actually doesn't produce the AIC, that's why I didn't put it in here, right? So if you just want to take a look, right? So we're going to just run all these lines of code, and then I'm going to just type in best to see that's basically what is being presented right now, right? So the best model with just one predictor, x8, he has 2 coefficients. Its R-square is that value, its adjusted R-square is that value, its MSE is that value, right? Its CP is that value, and its BIC. I believe they sort the best by BIC, right? Obviously, one of the things I say, right, is that there are all these different criteria, and they don't always agree. Usually, there is some consistency, but they don't always agree, right? So a few things you could do is to use the function order. So I'm going to order my data frame best based on R-square. right? So I'm going to sort it, and the order function sorts it, I believe, from smallest to largest. So it's going to sort it based on R square from smallest to largest. So you can see the largest R square is this model here with all the predictors except this middle one, which is x5, right? So that's the best model based on R square, right? And if you want to change the criteria to say adjusted R square, you can just run that line, and then you can just take a look. But adjusted R square, I believe, is this column over here, and the highest adjusted R square is the model with 4 predictors, right? X2, 7, 8, and 9, right? So you can kind of sort it. So you notice it's a little bit different. And we know R square, right, always chooses the one with the most number of potential predictors. Some other things you could do, right? Sort it by MSE. And again, MSE, the smaller the better. So basically the best model is the one with the smallest MSE, which is the first model sorted here, which is X2, X7, 8, 9. So that's still the same, right? Whereas if you do maybe try, so let's just take a look at some of the others. CP again, from smallest to largest. So the one with the smallest CP has just 3 predictors for X2, X7, X8. So you kind of see that, right, it's not always the same, that the various criteria not necessarily agree, although there is sometimes some consistency. So that's all possible regressions. The next thing I want to just show is using the automated search procedures, right? So we'll be talking about forward selection, backward elimination, and stepwise regression. So usually when I carry out these automated search procedures, I typically like to set out from what I call a null model, i.e. an intercept-only model. So to write an intercept-only model, LM, my response tilde 1 to just say I only want the intercept. It's probably useful to specify which data frame you want to use. And I'm going to consider the model, I'm going to call it regfull, basically the model which uses all predictors. Basically the reason why is I'm going to use this as like my starting point, and that's my end point for my automated search procedures, right? So I'm going to just fit these models. So to carry out the forward selection, I use the step function, reg null, because I basically want to start it from the intercept only model. And this list is basically saying what's the upper and lower bounds of my models I want to consider, right? So I want to consider the intercept only model as the lower bound and the model with all predictors as the upper bound, and then direction I put forward. With backward elimination, right, I change this to backward, and my starting point has to be the full model, right? Because I want to start from the fullest model and start removing predictors. So I'm just going to run the forward selection here just to illustrate how to read the output a little bit. So let me just try to highlight this line. I'm going to run this line. So let's take a look. So let me just scroll up a little bit from the start. So again, this is a forward selection procedure, right, where I'm starting from the intercept only model, right? So to start, it says intercept only model has AIC 70.81, and then we'll consider adding each of these predictors first, right? So the best predictor to add first is the 8th predictor, right, because it has the smallest AIC. So that's the first step in the forward selection. So after adding the 8th predictor, then considers adding any of the remaining predictors, and the best predictor to add will be X2 because it results in the lowest AIC. And it continues in this manner, right, one step at a time until the AIC no longer improves with the addition of a predictor. So at the end, it tells me that these are the 4 predictors based on forward selection. The output is similar for backward elimination. Stepwise regression, it alternates the directions. Now, one thing I will say is the following, is that with automated search procedures, they don't always agree, and also it could depend on which model you start with. So I'm going to start with, say, this particular model, y tilde x1. So this is saying my starting point is going to be the first predictor. And I'm going to run this stepwise regression and see what the result is going to be. Notice it has x1, x2, x8, and x9, which is a little bit different from my forward selection where I start from the intercept only model. So with automated search procedures, right, it depends on your starting point, and even if you use the same starting point, right, using the different, whether it's stepwise or forward or backward, it could result in different quote unquote best models, right? So I always view automated search procedures and even the all regressions approach as kind of a starting point for you to start, right? And not the final model that you want to think about. Now, when would you want to consider to start a model like that definitely includes, say, the first predictor? So in that instance, right, it will be based on expert knowledge on the subject, where you say that, yeah, this is a predictor we definitely have to add in, right? We cannot not consider this predictor. So there are some situations, and that's going to be very contextual based on the subject and expert knowledge on the subject.